In this tutorial, we will have some fun with a couple of activities for Pi Day. Just to clarify, while September 29th of 2023 was one of several great Pi Days in Australian history, in this session we're actually referring to the 14th of March, where we write the month, then the day, as 3/14. We will start with some clever sums using the summation tool. Press the Maths key, select option 5, and now we're ready to populate the summation template. To understand how this template works, let's add up the whole numbers from 1 to 10. We start with x equals 1 and conclude with x equals 10. Our expression is simply x. The first number to be placed in the expression is 1, then 2 and 3 until we reach 10. So the calculator generates the answer quite quickly as 55. We can change the terminal to add up all the numbers from 1 to 100. And that's certainly quicker than doing it by hand. The mathematician Gottfried Wilhelm Leibniz established a simple sum for pi. 1 minus a third plus a fifth minus 1/7 plus 1/9 minus 1/11 and so on, forever. The first thing you may notice about this summation is that it alternates between positive and negative values. This can be achieved in the summation by raising -1 to the power of x. So if we start with x equals 0, then -1 to the power of 0 will just be +1. When x is 1, we have -1 raised to the power of 1, and so the answer is negative. In general, the odd powers will generate negative numbers and the even powers will generate positive numbers, and so the sign alternates. The denominator of each fraction is the sequence of odd numbers. This can be achieved using the expression 2x plus 1. When x equals 0, our expression yields 1. When x equals 1, the expression yields 3, and so on. So overall, the formula looks like this. Let's have a look at the sum of the first 10 terms. We get 0.76, which hardly looks like pi. But if we multiply this result by 4, then we get 3.04. Not bad, but it's not exactly pi, unless you want to round it off to the nearest whole number. We can make our sequence go somewhat longer by adding up the first 50 terms. Multiply the result by 4, and after a little bit of time we get 3.12. Now that's a bit closer. What if we add up the first 100 terms and multiply the expression by 4? This sequence is relatively slow to converge. The beauty here, however, lies in the simplicity of the summation. But let's try a slightly different sequence. This time I'll set the upper terminal to a. That way the summation can easily be edited by just changing the value of a. The sum of the first 10 terms is 3.141. That's a much better estimate and with a lot less terms. What if we sum the first 40 terms? Now our answer is so close to pi, we need to check it. And one more sum. This one looks a bit like the first one, but let's see whether it's any better. We'll sum up the first 20 terms. We get 3.14159264, which compares extraordinarily well to pi. It still doesn't equal pi, but it's not bad. So, that's all for our sums. Hopefully you enjoyed this little slice of pi. If you would like to see more ways of generating pi, check out our other video titled A Piece of Pie for Monty. Thanks for watching.